Well, welcome back. We're going to go ahead and finish up this first IF can, I hope. And I want to get it done so I can move on to the next one, which is a little more complicated, but basically the same thing. You know, wires need to be changed out. A couple of resistors on the next IF can T5 need to be checked. But back to what I was telling you yesterday about these two wires coming out of the top of the IF can. Normally there's only one wire that comes out of the top of an IF can, but this one has two. One connected here and one connected over here. And I was afraid I might have confused somebody, or maybe a group of you, maybe all of you, about what I was talking about. Here's the IF can right here, but as you can see there's only one wire that comes out and connects to the grid cap of the 58 tube. A single wire. But yet we have two wires. What they did was take a wire and connect it to the ground on the inside. Let me use my pen, it might be a little easier. They connected a wire to the ground on inside the can, okay? And then they ran that wire out through the same hole as the grid cap wire. It comes off this capacitor. Now they're not connected together, but what they did right here is they wrapped it around and around. They stripped all the insulation off it and wrapped it around and around and around and around, just like that, and then put a little sort of a metal clamp around the outside that held the two wires together. Now any noise or interference that would come in from another part of the chassis, or for all I know, from anywhere, that would get on that grid cap wire and interfere with that grid and that tube operation, anything that would hit would try to get into that wire and go this way would be picked up by this little wire that's fastened back to ground, and that noise and those frequencies would go back to ground and be taken away. Alright, I hope that little explanation helped a lot. Now I have to make an evaluation on this thing. The wiring is rubber coated, of course, and it is really brittle. And what we've got is the green wire comes in the bottom here. You know, sometimes a person will look at the inside of an IF coil and say, my God, what a mess. What are all these wires? They're not that difficult. Again, you've got a green wire that comes in the bottom. We already know that. And then it runs from here, this little tiny bulge, which obviously is a coil. It runs up the green wire up to this capacitor, this trimmer cap right here. Now if we look on the schematic, that's what we've got. We've got the green wire coming in, hooks to that little bulge, that little coil there at the bottom, and it also hooks to the trimmer cap. Up to the trimmer cap, down to the coil. Nothing to it. So now what I've got to do is I'm not going to disturb this green one. I've decided not to cut and change that. We have to kind of pick our battles here. I'm going to go ahead and put a new wire on this green one, this white one, and this brown one. But this wire that runs up to the trimmer cap, I'm just going to coat that with some of that Corona dope, and I'm just going to leave it because it's all cracked and everything. And I start messing with that thing, I don't know what can happen. I don't want it to break loose at the bottom of the coil here. I'd be asking for trouble, you know. But I'm going to take this one off. These two wires that are sticking out of the top of that IF can are coming off. And these, I'm going to cut the brown wire right about in here somewhere. I don't want to cut it too short. Cut it about in here. And fasten a new wire on. So I'll have those nice three white, green, and brown coming out of the bottom. And the two black ones. I might, it's interesting. I may go with an orange wire coming out of the top of the IF can going over to the grid cap. I might decide to go with an orange wire. That would be cool. And then for the wire that comes from ground and wraps around, I'll use a black one for that. Now, since there's no color labeled on there, I'll just consider it my option, my prerogative. Alright, one more thing. These two screws right here, this one and this one, are the trimmer cap screws. This screw right here is just it holds a piece of cardboard on with a spacer in between, and it keeps the metal from the can from touching those two eyelets you see there. See, it's just an insulator. That's all. They mounted on top of a spacer. So let's take that insulator off, and I've already cracked loose the screws on the trimmer caps. They have to be loose because when I put it back in there, I may need to do an alignment. And you know, if they're rusted shut or they're rusted to where they won't turn, you got all kinds of problems. You have to take it all back out of the can. You know, now is the time to deal with that. All right, this here insulator has been removed. The screw has been taken out. Not a problem. Now what I'm going to do is take the screws out that hold the mica in for the trimmer capacitors. Now, unfortunately, the mica that's sandwiched between the two top and bottom pieces of metal right here, the mica is fastened all the way to the rear here, and it looks like it's been riveted on. The rivets go right through it. So what we're going to do is take some alcohol and a brush. We're going to clean this place up really good. It's really rusty and dirty. And then I'm going to spray the whole thing down with some QD electronic cleaner. We're going to spray down between the plates and everything, and then give it plenty of time to dry. Alright, we've got it nice and shiny. It's all been sprayed out with this QD electronic cleaner. And we'll let it dry. And while it's drying, we'll go ahead and take the rusty screws and washers that were in there. They were pretty bad off. We're going to just go ahead and plunk them down in the old navel jelly and let them soak for about an hour. We'll get those babies clean. Alright, now the next step is to go ahead and start changing out some of these wires. Instead of talking about it, let's have a little more action here, huh? This round disc I discovered was also loose. It rotated left and right. Now normally it would be tightened by this nut on the bottom down here. But you know, I'm not going to be tightening anything up on this because it's so brittle and just so messed up that the slightest movement could pull out the wires, because you know, you can see right here that this wire connected to that round thing goes down into the coil, and this one right here, this black one right here that goes to ground, also goes into the coil. Don't want to take any chance of ripping those out. So what I did is I took some super glue and I squirted it, lots of super glue, down in here, all the way around, to keep that thing stable and not moving. It's the only way you can really do it. I didn't have to use super glue. I could have used, you know, epoxy gel, 5-minute epoxy gel, anything you want down in here. But the object is to go ahead and keep it from moving. You don't want it rotating left and right, especially when you're, going down through the IF can with your screwdriver, doing your alignment, and you're turning those trimmer cap screws. You don't want that thing to be rotating on you inside the can. Bad news there. It is time to insulate this thing. I was going to use Corona dope, but that stuff's awfully expensive. Really expensive actually. It's overpriced in my opinion. So what I'm going to do is go ahead and use some good old liquid tape. That'll do the job. It's about half the price of the Corona dope. Anyway, we've got our white, brown, and green wires spliced on, and I put green heat shrink over each of the connections. And now all I have to do is cover everything with the liquid tape. Now before I did that, I went ahead and I ohmed out the wires again just to make sure that I'm still getting continuity, and I am. You can go back to the video where we did that. It was the green and the white and the brown and what is now the orange, which earlier had been the black wire. But we're good to go on that. I have not yet put the screws in or the washers for the trimmer capacitors. We'll do that next. Right now, let's just see what we can do with that. I've got them taped together and kind of over in an angle because I don't want another smashed wire here. I don't want to repeat what we found when we opened up the can. Alright, the first coat has been applied and it's all dry. It looks pretty good. There's a couple little spots though that need to be touched up. So what I'm going to do is go ahead and see if I can't get that done. Just take the old liquid tape and just kind of let it run down in there. Put a double coat on those wires that were totally bare. I don't like that. And this old wire here that was just all busted to pieces here, the insulation was, old rubber insulation. Alright, now I'll just look around the other side and see if I can do the same thing over there, and then we'll let her dry. I have removed the orange wire from the top of this IF transformer. I'm not going to use the orange wire for the grid cap wire. I was going to use the orange wire, remember, and then take a black one and wrap around the orange wire just like it was originally. But instead we're going to go with shielded audio cable. A small piece of shielded audio cable. I'm going to strip this baby back, oh, maybe to about right in this area here. Somewhere in there. I haven't quite figured out exactly. I've got to kind of measure it. And then we're going to, pull back the shielding, solder it up, and then I'm going to, let me get this piece of tape off of here I put on that tab while I was putting that liquid tape on there. There we go. Alright. The shielding will be soldered to this tab right here. Okay? And the center wire, the center core wire, will be soldered right there, that shiny bump right there. Right there. Now what this stuff is just regular old audio cable. It's got copper shielding around the outside. The center conductor is not solid. It is stranded copper wire also. So we'll go ahead and solder that up. Well, I'll probably cut it in half somewhere down here. It's a little bit too long. And then we'll go ahead and get this thing, once it's all done, I've got to put this cardboard protector back on, of course, that goes over the top, which will protect the contacts. Let me get this over here where you can see what I'm talking about. It'll protect those contacts when they go up inside the can. Okay? This screw holds it on. And then we'll go ahead and slide it back in the can and see what it looks like. The shielding has been stripped back, and I've got it laying against this tab right here, and I'm getting ready to solder it up. So we'll do that one first. Alright, the wires are soldered on. As you can see, the ground shielding is soldered to this tab here, and the center wires are soldered to this lug right here, which goes down into the coil. But I don't quite like leaving this all bare like that. It'll probably be okay, but there's going to be quite a bit of flex on this thing. I want a little more strength down this area here. So I'm going to take a little bit of liquid tape, kind of insulate that right there. It's a ground, I know, but I'm looking more for strength than I am insulation, really. Well, that's it. We've got everything covered on that that needs to be covered with that liquid tape. It really made it strong. I mean, it really did. No more flopping around. I was really worried about those wires possibly breaking or something. Anyway, all we have left now to do is to get it in the can. I've got here a sheet of plastic I bought at Hobby Lobby. I remember the last time I bought one, it was twice as big and about the same price. Now they've shrunk it down to 50% and kept the price the same. Real nice, guys. Anyway, it's extra thick plastic used for making templates. It's over in the quilting department at Hobby Lobby. Works real good, by the way, as a light diffuser. If you ever need a light diffuser for your radio, works great. Anyway, I went ahead and bought another sheet because it was all out. What we're going to do, I've already done it actually. I cut a piece, the width I needed, which is the height of the IF can. Then I cut it, I slipped it inside, I cut it down a little bit further, and then turned it into a, whoops. I like that springiness about it, and you'll see why. Anyway, I made it small, put it inside the IF can, marked it with a pencil to where it would, come right together inside the can and not overlap like this. I didn't want it to overlap. I wanted it to butt right up against one another inside the can. You mark it with a pencil, and you take the old scissors and just cut it. And I'll show you how it fits now. There it goes, right inside the can. And I'll shove it on down in there, and that's what's going to take the place of the cardboard around our IF transformer. It'll insulate very well from the can. Now if you take your time, it butts up perfectly. Perfectly butts up. There's no space or nothing there, but even if there wasn't, it wouldn't make much of a big deal. Just do your best, and it's the right exact height. I'll tell you what, it's going to be the perfect insulator. And because of its springiness, it holds itself against the wall of the can. Good deal, huh? And there she is, back down in the can, well insulated from the outside. Fits perfectly. It's interesting that Atwater Kent never had holes in the top of the can lid in order to, at least in this model, to where you could, stick a screwdriver down there and adjust those two trimmer caps. So in order to do it, we have to remove the lid. Interesting, huh? Alright folks, we started with a can that looks similar to this one right here, except the lid was all caved in. And after a little time, a little effort, a little elbow grease, and lots of patience, we were able to take something like this and turn it into something that looks like this. It can be done. You just have to be able to, hang with it until you get it the way you want it. So we're going to go ahead and declare this can restored. Next video, we'll go ahead and pop this baby open and do the same thing. I'm not going to show you step by step how to do it. You've already seen it done with this one. It'll be exactly the same, except inside this can there's a couple of resistors, and I will change those out. And we'll cover that next time. So, I hope my old buddy, Texas buddy George down there, Mr. Oddsmaker, I hope he's taking some notes. Until next time, this is John. Tell you what, before we close out this video completely, I thought I'd give you a little sneak peek at what was inside this other can. Check that baby out. Look at all that stuff. Now I ask you, doesn't that look like another piece of cake?